Okay, let's go over a few questions and make sure we are all on the same page. So on exam 3, question number 1, there is quite a bit of confusion about part B. So the population, U.S. adults. Okay, population is not the U.S. adults that are concerned with COVID. It's just U.S. adults because we're looking at what percentage are concerned with COVID. Okay, but the actual population itself is just the U.S. adults. But parameter has to be a number describing the population. So if you just said U.S. adults that are concerned with COVID, that's not talking about a number. And I know you don't know the number, but you still have to use the word proportion or the word percent, something along those lines, because that's the number describing the population. Okay? Good? Everybody okay with the fact that 31 is a statistic? Because it comes from a sample. And this question right here, is there any sampling error? My follow-up question to that was there a sample? Read the question. Was there a sample? Yeah, they randomly selected 1,100 American adults. There is a sample, so there is sampling error. It's that simple. If there is a sample, I don't care how well picked that sample is or how much that sample represents the population, there will always be error because a small group of the population will never match the whole population perfectly. Okay? The only time there will not be sampling error is when? Yeah, when the sample is the whole population, or when they never picked a sample, they're just having numbers describing the whole entire population. Okay? Even if it's a simple random sample, even if it is the most perfect sample ever, there is still sampling error. It's still going to be off. Okay? All right. Question number 2. Most people did not have difficulty with part A. Just a quick flashback to this math, though. Your expected value is the average of the box. Okay, a couple people yesterday asked me what 8 plus 16 divided by 2, what that was, why they divided by 2. It's just finding the average of that box. Multiply by the number of draws, that's going to tell you what your tickets would all add up to if you drew 400 tickets. But because they're both 4,800, the question isn't about which box has a higher sum or a lower sum, it's which one you would be able to make a better prediction about. Okay, why is box 2 easier to make a prediction than box 1? Yeah, there's less variability, there's less width to your data set. So guessing between 4,000 and 5,600 is much easier than trying to guess the right number somewhere between 3,200 and 6,400. So do you see these 3 bullets? Trying to zoom in so people on the video can see, but not so far. Okay. Do you see the 3 different bullets? You did not need all 3 of those. You just needed one of those to justify your selection of box 2. Okay, and again, wording doesn't have to be perfect, but it's got to be something along those lines. You did not have to calculate SE, but calculating SE is support for box 2. You could say it's just a smaller standard deviation for box 2. You could just talk about the range of values is smaller for box 2. Good? Any question? Okay. Next. Accuracy of your surveys is 100% determined by what? Well, not 100%. Does it matter how big the population is that we're choosing from? No, it does not. Okay? The thing that matters is how big the sample is. So if there's a sample of 1,200 people versus a sample of 400 people, the 1,200 is more accurate. It doesn't matter how big the population is that it was picked from. Yeah? if your question was, you know, this city did a survey, 1,200 people, and it was a simple random sample of all the citizens of their city, this city just did a sample of 1,200 people by standing at the door to Walmart, then the more accuracy would come from the simple random sample that was executed well. But when you don't have that other information, or when they're both the same like gathering technique for the sample, then it's just size that matters. That's it. Good? Okay. Okay. Number 4. This one shocked me. I cannot believe how many times I had to take points away on number 4. And I honestly think it's because you didn't read. This is talking about a 6-sided die. And a lot of people did this problem thinking flipping a coin heads and tails, because the problem on the review was flipping a coin heads and tails. Okay? A 6-sided die, if it's rolled 600 times, each result is going to show up 100 times. And I had a few people that thought the expected value here was 300. Because if you toss a coin 300 times, then you would get, or 600 times, then you would get heads or tails 300 times. But this is talking about a 6-sided die. So each result should show up 100 times. So that tells you that your chance error, remember, chance error is just how far off we were that time. Yeah? If we got 126 and we were expecting 100, our chance error is 26. Yes? Okay. So this is how far off we were. It's called absolute terms because I haven't done anything. It's the absolute distance between what was observed and what was expected. Yeah? But as a percentage of tosses, it literally says right there to find that same chance error, but as a percentage of tosses. How many tosses? 600. Okay, I had people putting 100 down here, people putting 300 down here, people putting 126 down here. I don't know what to tell you. It's as a percentage of the tosses, which means you divide by the number of tosses. 4.3%. Good? Does that clarify that one? I know we missed that a lot, but hopefully that fixed it. Okay. Now, question number 5. Hopefully on your actual final exam, if there's a question like this, it will not be quite as wordy and quite as confusing. I don't know why this won't. It's not that won't focus. It's this. Oh, well. Doesn't matter. Okay. So question number 5. So CNN News invites visitors to their website to answer the following question. Are they forcing anyone to answer the question? No. Are they going to get a random sample of the whole population? No. Okay. This is what we call a voluntary response sample. So you see voluntary response sample in 3 of your multiple choice options. This is not a simple random sample. That would require putting everyone in the US into a hat and pulling out some, however many random names, 50,000 apparently, and having them answer the question. But that's not what they did. They just said, if you want to answer the question, answer the question. Okay? And it is not a census. A census, by definition, means that we asked every single person in the US. Did we? Every person could have answered if every single person visited CNN's website, but it wasn't manufactured that way. It wasn't built to ask every single person in the US. Okay? You guys get that that's basically impossible. Yeah? Like they still do the census every few years to try to gather data, but then there's people like me that never send their paper in because I'm special. Until I get like the 7th reminder, and then I do. But the first time, heaven forbid. Okay. All right, so moving on. So it is a voluntary response sample, so then we have to decide which of these 3 arguments is true. So The question was, do you believe President Trump should have been impeached even after he left office? And 85% said yes, he should have been impeached. So our question is, who is answering and why are they answering that way? And that will help you decide what your answers should be here. The way we're looking at it is current political climate, yada yada, what's all the stuff that's going along with that. And we think that the people that are responding to the survey are probably the people that are the most irritated with President Trump. Generally speaking, when there's a voluntary survey, you don't respond when you're pleased with how things are. You respond when you're mad. Yeah? Have you ever eaten at Chili's and after you pay with the little thing, it asks you to take a survey? I always skip the survey unless it was garbage. And then I do the survey. That's just the way I am. When I get an email survey about my visit to a doctor's office, I don't do it if everything was fine and if I got in at a decent time and yada yada. But after my leg surgery, when my appointment was awful and they were eating Cafe Rio in the same room they were putting my cast on and like talking about me in the hall where I could hear, and the doctor never even like once stepped foot in the room, and they were an hour and a half late to call me back, like all of those things, I was like, yeah, I'll fill out your freaking survey. You bet I will. Yeah? Okay, anyway, so we are going to go with option D. Okay, this is not a probability sample. It will almost certainly overestimate the percent of Americans who believe President Trump should have been impeached. Again, because when we're upset, when we're mad, when things didn't go our way, we have a tendency to respond to surveys, not when we're happy and everything seems fine. Good? So that right there, knowing it was a voluntary response sample, that's statistics. That's your job in this class, to know that vocabulary. The rest is like a common sense. You have to kind of have a basic understanding of how the world works. So I can't really teach you that. That's something you're going to have to pick up on your own eventually. Okay. Number 6. Same idea here. In the current political system, when people are asked about racism in law enforcement, at this current time, it seems like the number of people that think that police officers are racist is pretty high. Why? Because it's all over the news. Every little teeny tiny thing that police officers do wrong is in our face. So there is probably a high proportion of people that would say that right now that wouldn't have said it a year ago and probably won't say it again in a year. Yeah? So we're just in a weird spot right now. So we anticipate that less than 89%, just because of that concept that it's kind of a hot topic right now. I will say, however, some of you are probably noticing, oh, I totally got this question wrong, or a different question totally wrong, but I still got some of the points. It's because if you can still argue something that makes sense, something logical, I will give you the points. Okay? So like if you had said, I think it's more than 89%, but you had like a solid argument for that made sense to you and that you can put into nice, readable, understandable language, then chances are I'll give you at least half of those points. So it just kind of depends on the question. Okay? All right. Number 7. Most popular mistake on number 7 was this guy. Actually, both of these. So a lot of people had 7.1 in this box. Somebody explain to me why that is wrong. I mean, 7.1 is in the problem. They told you it was 7.1. Why am I suggesting that it's an estimated number and not a known value? What is 7.1? What does it say in the wording? SD of what? It's the SD from this random sample. That's where that number 7.1 came from. It's the give or take from this sample of 25 values. What is this question asking you for? SD of the box. Everybody with me? Okay. They're asking for the SD of the box. Is this the box? Are there 25 tickets in the box? How many tickets are in the box? We don't know. There's definitely not 25, right? There's 25 tickets in the draws, and the variation of those tickets is 7.1. I have no idea what's in the box. So I definitely do not know the SD of the box. If I can't even tell you how many tickets are in the box, do you think I can tell you the exact measurement of how varied the numbers are in the box? No. Okay? But I do have good information coming from my sample that I can just assume is true about my box, but it definitely makes it estimated because I have to guess that. Then if I'm estimating this guy, I have to use 7.1 in order to come up with the standard error. Since 7.1 was an estimate, so is my standard error. Now, everybody look up here. Eyes on the screen for a second. Do you see the difference in size here? SD is 7. SE is only 1.4. The variation on a sample, just like the variation from the age of pennies as we move from a sample of 1, aka the pennies graph, to a sample of 25, aka the quarters graph, what happens to the variation in those two graphs? It like significantly decreases, yes? Do you know what I'm talking about? Much less variation. If I'm taking all of those averages, all of those ages, whatever I'm taking, if I take those and I average 25 of them, I lose a lot of the extreme high and the extreme low. Okay? So that makes my variability or my give or take much lower when I'm looking at the whole thing instead of just the teeny tiny, like a sample size of 1 would be the pennies. Your SE should be smaller when we're dealing with averages like this. Your SE should always be smaller than your SD. SD is how much variation there is from ticket to ticket to ticket to ticket. SE is how much variation there is when I take the average of 25 tickets and the average of 25 tickets and the average of 25 tickets. Okay? So this was one that I marked wrong a lot. And it's because you weren't using SE average, so you didn't divide by 25, which made this number like 37 or 35 or something big. I can't remember. But it was huge. Your SE should not be that much bigger than your SD. Okay? Does that make sense to everybody? Okay, so just watch out for that. How did I know right here? How did I know to use SE average? Because it says average in the problem. That is a dead giveaway on every problem. If it says average, please just do the whole thing with averages. Yeah? Please, I'm begging you. Sometimes it's not that obvious, but when it literally says the word, please use that formula. Okay? All right, next. I don't remember if there were any issues with this one. Does anybody have questions about number 8? So we changed the box to 1s and 0s so that we can count, because it says number of tickets marked 5. It just wants us to count the 5s. So I changed the box so the 5s are adding to my tally and nothing else is. Everything else is a 0. Yeah? Draw 400. So I came up with my EV and my SE. It does not matter if you use sum or count. Right here, it will give you the exact same answer. Anybody know where the 1/8 and 7/8 comes from? Good. Proportion of 1s in the box, 1 out of 8. Proportion of 0s in the box, 7 out of 8. Okay, so I expect 50, give or take 6.61. When I draw 400 times out of this big box right here, I expect 50 of them to be the number 5. Give or take 6.61, or give or take 6 of them or 7 of them. Yeah? Now, the word observed. This is killing me. What does it mean to observe? You saw it. This actually happened. Is 50 what I observed? No, I used a fancy formula to get to that 50. I didn't observe that I got 5 50 times. How many 5s did I observe with my own eyeballs? Yeah, it says right here, the number of tickets marked 5 is 58. So that's an observed value. Chance error is the exact same as it was on this page. Chance error. It's the difference between what you thought you were going to get and what you actually did get. So if I was supposed to get 50, if I was supposed to get 50 5s and I got 58 5s, my chance error is just the difference between the two. It's 8. Yeah? So what is this number then? What is 6.61? But what is SE? Which is what? It's a number. What does 6.61, or let's just call it 7 for a minute, what does 7 tell me about this data? It's the give or take. I was supposed to get 50 5s, give or take 7 or so. Yeah? Because it's never a perfect science. I don't look at this and go, yep, I'll get 50 5s exactly. No, I won't. Okay? It'll fluctuate a little up, a little down, a little up, a little down. And the amount that it should fluctuate every time I draw 400 tickets is by about 7 tickets. That's how much it should be fluctuating. How much did it actually fluctuate this time? 8. It should have fluctuated about 7 off of 50, and it was 8 off of 50. Are those close? Yeah. So that seems like, oh, okay. Those two numbers should be pretty darn close to each other. How far off you actually were and how far off you expect to be. Yeah? So chance error is observed difference. SE is the expected difference. Yeah? Observed, give or take. Expected, give or take. Got it? Okay. There's that word observed again. What does it mean again? You actually saw it. Is the 120 something you actually saw? Yes, it is. It actually, oh, I skipped number 9. Funny. Do I need to talk about this one? Okay. So the answer is question 2, because question 1 has the word Obamacare, which may have had a negative connotation. So not as many people wanted to vote for Obamacare as the Affordable Health Care Act, because everybody wants things to be affordable. Here we go. Number 10. If you read this, it says, in a survey of 300 males, 120 indicated that they have heart disease. That is what you observed, you saw with your own eyes, supposedly, or these people did, that 120 people have heart disease. So 120 is an observed value. Yeah? But then, look at this. SD of the box. If you read the question again, they would like to estimate the percentage of males. So they're saying right here, they would sure like to know what's in the box, quote unquote. But all they know is that out of 300 draws from the box, they got 120. So they don't actually know what's in the box. When we come up with these numbers right here, we are guessing that what's in the box matches what we saw in our sample. So it's an estimate. And if I'm estimating what's in the box, then I'm sure as hell estimating heck. recording right now. Gosh.
Oh, I was like, what are you?
I should have rewound the video. Sorry, everybody. Sorry. Don't tell your parents that I said the H word. You know, I bet they are. They want to learn some stats too. Anyway, if the box is estimated, then surely the standard error is estimated as well. Okay, good job. All right, moving on to number 11. Guys, if I think I know anything about UVU and what's going to happen on this final exam, I am like 99.7% sure that there is a question like number 11 on your final exam. I haven't seen it yet, but 4 years in a row we've had this question on a final exam. So I'm thinking maybe we should know what we're doing. Sound like a plan? Okay, so a lot of you did fine on part A that was on this page. Some of you missed a few details. I tried to be nice when I was grading it. But then you get to part B and it just all goes to wherever it goes. So, at a local high school, 15% of students are involved in at least 2 extracurricular activities. When you read this statement, you all listening? When you read that statement, you have to understand that they are giving you a fact about the population. This is not 15% coming from a sample. It literally says 15% of the students are involved. Done. No sample involved. Yeah? Which means we're defining the box.
I was going to ask you to borrow Jack, but I don't see Jack. He's already in trouble. Somebody else is already.
He got a note from the counseling office, one of those cute little green ones. Okay, where was I? Oh yes, here. So 15% is not from a sample. It is a fact about the population, so it defines our box. Okay? Does your box have to look exactly like mine?
Yeah.
Really? It doesn't. Okay? Be nice. We could have, let's see, we could have like 20 tickets. You could draw me a box with 20 tickets. 3 of them could be 1s and the other 12 could be 0s. No, that was not good math. I did something wrong there. 3 and 17. I was like 3 and 12. Nope. Okay. Anyway, there are other ways to do this. The problem is this. Are you guys ready? This is a major problem. That's it. Why is that a problem? Because then you move to the next page and you think you have exactly 2 tickets in this box. One of them is a 1, one of them is a 0. That works great for tossing a coin. We're not tossing a coin here. Okay? We've got a 15% chance. That is not 50. That will not work. You cannot just do that. You have to identify what proportion or percent of the tickets are 1s. You also need to label what they represent. You also need to tell me how many draws. And if you have facts about the draws, you should list those as well. Okay? So now we move on to the math. And because you kind of sucked at this one, we're going to do it from scratch instead of just looking at my paper. So back to our box. We have a box with 15% 1s, 85% 0s. We are going to draw how many tickets? 500. Find the probability that of the 500 randomly selected incoming freshmen, fewer than 60 are involved in at least 2 extracurricular activities. So we already have a little bit of I can't think of the word. Like a disagreement, I guess, because in the beginning, our numbers were given to us as a percentage. Now it's just talking about counting 60 people. Guys, listen. So we have to decide right now before we proceed if we want to do the whole problem in percentages or in counts. It doesn't matter. You get the same answer either way. Okay? But you have to make a decision and you have to be consistent. I'm going to do it right now with counts so that I can actually compare the 60 that they gave me to something, and because it doesn't hurt anything to have the box in percentage form. Okay? So the first thing I want to do is find the expected value of the count or the expected value of the sum, because they're asking me what's the likelihood that it's as low as 60, but I don't even know what it's supposed to be. That's where expected value comes in. What is it supposed to be? Well, if 15% of the tickets are ones, when I draw 500 times, how many ones should I have? 15% times 500. So we expect 75 of the tickets to be ones. Okay, if you look on your formulas page, this has the phrase average of the box. But average of the box is the same thing as the percent of ones, or the proportion, I guess, not really percent. Percent of ones in the box, or proportion of ones in the box. 0.15, 0.15. Got it? Yes? Okay. Multiply that by 500, so I should get 75. I also am going to need a give or take on that 75 to help me out. What is the standard error formula? SD. How in the world do I find SD? They didn't give it to me. Square root. 0.15. 0.85. Times square root 500. Do I divide? Here's one way to think about it. Multiply them first. Okay, if you're unsure, first of all, hopefully, if you didn't use the word average or percentage, you know not to divide. But if that's not the case, try multiplying these. If you multiply these, ask yourself, did I do that right? I got 7.98, so I basically got 8. Okay, if I divide that by 500, I get 0.015. Which one of those two numbers makes sense when I say I'm going to draw 500 tickets, 75 of them should be ones, give or take 8, or 75 of them should be ones, give or take 0.015? Because this is basically saying it'll always be 75. By the time you round, it'll always be 75. That doesn't make any sense. Okay? So check your SE. Make sure it makes sense as a good give or take number on your expected value. All right, what about observed? Just curious. What was our observed sum? How many ones did we actually observe? We haven't really. It wants us to find a probability of getting 60 or fewer. So that's basically like our observed value. It just wants to know how likely that is. Okay? What goes right there? What I expect always goes in the middle. Okay? Because remember, the most data is going to be right here. So it should be centered at what I expect to have happen, which is 75. How big are my gaps? 8. So if I go down 8, that's not hard. Maybe it is. What is that, 59? Wow, math is hard. Okay. Question is, read it again. Find the probability that of the 500 randomly selected incoming freshmen, fewer than 60. Can you mark on here? Fewer than 60. Does that look like fewer than 60? Yeah. So it wants to know what that probability is. Okay? Hopefully you remember how to use normal CDF. If not, you got to get a z-score and look it up in the back of the book. Which is fine. You guys have been practicing doing that, so you should be fine. If I wanted to do it with the book, z equals observed minus expected over SE. 60 minus 75 equals negative 15 divided by 8, negative 1.875. So I would look up 1.88 as a z, or 1.75 as a z-score. And find the area. But that area, if I look it up in the book, is going to give me this middle section, right? So then what do? Subtract from and divide by. Or I just use normal CDF. What does this look like with normal CDF? Normal CDF, what's my low? Negative 9s. My high? 60. Middle? SD. Also, please remember that normal CDF is going to give you proportions. You have to move that decimal if you want percentages or to get a p-value. Okay? So this is 0.03, or we could say it's 3%. This is not a significance test. This question is not asking you to run a significance test, but you could have. It could have asked you, you know, the claim is 15%, but we only got 60 out of 500. How likely is that? Or run a significance test to see if the claim might be wrong. 3%, significant or not? Significant. So we would have to reject the null hypothesis, but our null hypothesis is always that there's nothing wrong. There's nothing different. So if we're rejecting that, then we're saying something is wrong or something is different. That percentage of 15% doesn't exist anymore, whatever. Okay? This particular question, again, was not asking you to run a whole test, but this is a p-value. This right here that I've been pointing to the whole time that you can't see, that's a p-value. Okay? 3% is a p-value. The area that you get from a normal CDF or the area that you get from using the table in the back of the book is always a p-value. And if that p-value is less than 5, we've got significant data. Something's wrong. Reject that hoe. Good? No, it's fine. It's fine. I don't even care. I'm over it. Okay. Number 12. This guy right here was the most commonly missed number on the whole entire test. Next time you're tempted to put 33 that they put in the question in the blank, you're wrong. If they gave you the number, I probably wouldn't ask you to find it, especially twice in a row. They gave you 1020. This is not going to be another number they gave you. Just a word to the wise. Okay? A give or take. A give or take on a true average has to be an SE. A lot of you put 33 right here, which is the what? SD. Okay? The give or take on the number of cars on any given day is 33. I repeat, the give or take on the number of cars going through that intersection on any given day is 33. But the give or take on the average number of cars going through that intersection has to be your SE. Same concept, pennies to quarters. This is the give or take on a sample of 35 days. So it should be smaller. It's not as extreme as the give or take on 1 day. Yeah? Any questions on that one? Then we get down to 95% confidence interval. It's just expected value. Give or take 2, but it's got to be that SE right there. Okay? This is another one of those questions where if you messed up right here, as long as you didn't mess up again, you got the rest of those points back unless it didn't make sense at all. Like if you were interpreting things totally wrong, then I had to take off a couple more points. But good? Any other questions on that one? Is that it? Okay. Are there any questions from your blue packet? The only ones from exam 3. Yeah, so if you have this, so let's look at this confidence interval right here. If you have that confidence interval, it's asking you, does their claim of 1030 seem plausible? If the number they're claiming is in your confidence interval, then you say, yes, it seems plausible. But if it's outside, because this is all this is saying is we expect on any give it or that any average of 35 days would be somewhere between 1009 and 1031. So 1030 or 1030 is not outside of that interval. So we say that it does seem plausible. Which is probably part of the problem. Well, you're just not answering the specific question. It just wants to know if their claim is 1030, is that plausible? Does that make sense? Yes, because it's inside of here. Yeah? Okay, so blue packet. The only 2 questions on your blue packet that really come from exam 3 are number 17, nope, 18. That's an 8. Number 18, and I believe number 7.
Yeah, number 7 has that concept.
Yeah, so make sure you've got number 7 and number 18. Next class, so on Tuesday, we will go through questions from the 4th exam. Okay? You should be working on that in the meantime, as well as the old stuff and the current stuff. Like, you just have to keep working a little bit every day. If you want to do well on this test, you have got to work on it. There is nothing I can do to help you get it besides just make you do more. Yeah? The more stats you do, the more stats you understand, period. Yes, sir. Okay. All right, just let me know if you have individual questions.